Hi, my name is Carlisle Binti Matius. This is my video presentation part 2 from week 7 until week 15 for the subject of Industrial Maintenance Technology. Lecturer is Ms. Sumaiya Binti Mashori. So, in week 7, we do a video presentation for part 1 that covering from week 3 until week 6. Actually, in week 1, we have the industrial talk by study tactic. And from the industrial talk, we did a mind map. Then for week 2, we have introduction to RPP, which is our lesson plan for this semester. So here, what I do in the video presentation for part 1. So from week 3 is introduction to safety signage, where each student need to prepare 10 safety signage. And before we have do a mind map for maintenance, which my part is predictive and preventive. So week 5, we are available to go to the laboratory. So we have laboratory and safety procedure briefing. Then we do have a laboratory rule and agreement, discussion on POPBL, and we have PLC training kit briefing, which is three types of PLC: on touch and control training, which is CSIG CPU42H and CQM1H CPU51, Yokogawa F3SPO05-0P, and Siemens Somatic ET200SP CPU151 to SPF-1PN. And then our lecturer have gave practice to understand the ladder diagram and the mnemonic code. So in week 6, we do a laboratory inspection, lab work. So, and in the lab work, we have as a trainer, the two trainer, but both trainer we can do testing because there is no USB cable to connect from trainer to laptop. So what we do is we only build a simple ladder diagram using a CX programmer. So this is the another option that we do while we cannot do the testing training. So week 8 we have a mix and break. So in week 9 we do online activity group, which is continuity test. Okay. So the first question is briefly explain the continuity test and use one application to support your elaboration. So the application must be supported by picture. Below here is the support picture. So a continuity test is a quick check to see if a circuit is open or closed. Okay, only a closed complete circuit. One that is switched on has continuity. This test is carried out by determining the continuity between the holes on the breadboard with help of analog multimeter. The second question is create a correct standard operating procedures (SOP) how doing the continuity test for the LED application. The step-by-step procedure must be supported with picture. This is the picture. So the first step is check the proper of installation of LED into the holder. Okay, step 2, make sure that the operating switch are closed. Then step 3, connect the digital multimeter and make sure that the connecting of the probe are correct by following circuit. After doing the connection and measure the resistance. So if the result show in a large, reverse the probe. If not, the connection is correct. Then step 4, measure the resistance as shown by the digital multimeter. The third question is the power supply had been supplied to the LED. However, the LED does not light up. Analyze the problem that might exist and propose the solution to encounter the problem. This is the picture of LED. So below is the some problem why the LED does not light up. So first, incorrect connection LED. So make sure now the correct polarity when wiring or install. Use multimeter to test. Then the second problem, the LED was damaged. So need to find a new LED to replace the old one and install with correct polarity. Next, maybe it's not properly installed LED. So take the LED out and reinstall it. The last one may have a dirt in LED terminal. So find the dry cloth and clean the terminal before install it. In week 10, we also do online group which is soldering. So the first question is to explain each type of soldering iron and its application. So electric soldering iron has a different type, shape and size. It can operate at varied electrical voltage. With low power, it can handle in 15 to 20 volt for electronic works and high power for 500 watts in a larger work. Second is battery soldering iron, which is it is quite safer and more accurate, and it very minimal risk of burning. It also quick and easy soldering tip replacement. Okay, the third is gas soldering iron, where it is widely used to solder metal materials together and easy to maintain and refill with butane lighter gas. The second question is familiarize with the standard operating procedure for soldering and desoldering process with, with the help of figure. So this one is the soldering. First step is heat both item at the same time by applying the soldering iron to the copper pad and the component lid. Step 2 is continue heating and apply a few millimeters of solder. Remove the iron and allow the solder joint to cool naturally. The step is it only take a second or two to make the perfect joint, which is it should appear shiny. And for the solder, there are two types, which is to use solder sucker or solder wick. Step 1 for solder sucker is apply heat to the connection to be desoldered, then trigger the solder sucker when the solder melts. Step 2 is repeat desoldering as needed until all the solder is removed. Step 3, remove the component lid. For solder wick is a finely braided copper that is used to wick away excess solder from a desoldered connection. Step 2, apply the solder wick and soldering iron to the soldered connection. The solder wick will draw the excess solder off the PCB pad. Step 3 is desoldered PCB pad. Number 3 is to differentiate between good and bad soldering based on the figure. So here is a good solder. We can see that the picture, the good solder is very small. It's bright, shiny, clean, and concave. It have concave fillet. Concave fillet. But for the bed solder, we can see it has a cold solder joint, not solder rod, have a solder bridge, and the solder has lifted trace or bed. So in week 11, we have joined the alumni industrial talk, which is PLC and SCADA application from industry perspective and experience sharing. So panel 1 is Muhammad Shukon and panel 2 is Natasha Mira, and the moderator for the industry talk is Kalangutan. So the panel 1 has sharing his uh, his experience working in the industry, which is PLC, which is PLC stand for Programmable Logic Controller, and it is use a programmable memory for the internal storage of instruction for implementation specific function. So this picture show that um, where is PLC used in their company, which is type Nachi type and Mitsubishi type. The second panel sharing about SCADA, which is SCADA is stand for Supervisory Control and Data Acquisition. SCADA is a set of software and hardware components that help industrial plants maintain their efficiency, process data for better decision, and communicate system issues to reduce the downtime. Okay, based on panel 2, in order to interact with SCADA system, the recover project editor and Inkscape were used. So we can see here is the software of recover and Inkscape that use with SCADA system in their plant. Next, week 12 is a public holiday, and week 13 we have a quiz, and week 14 we don't have any assignment, and week 15 is this video presentation part 2. Okay, that's all from me. Thank you.